By the end of this video, you should be able to describe what a parent function is, and you should be able to describe the terms function notation, domain, and range. A parent graph is the simplest or the most basic graph of a particular type of function. So for example, there are a couple of different ones that we'll see. Y equals x, that's the simplest linear graph that exists. Y equals x squared is the simplest quadratic function that exists. Y equals absolute value of x is the simplest absolute value graph that exists. So you can see that these are very simple graphs that pretty much have y and x and a single function, and that is it. So parent graphs are the simplest graph of a particular function. Now, children graphs use parent graphs. They are variations of the parent graph. So essentially what's happened is when we have a child graph or when we have one of its children graphs is the parent graph is transformed, translated, which means it's moved, or reflected to create a slightly different graph. So these children graphs are basically slightly modified parent graphs. And how I like to think about it is you have your parents, right? And your parents have some characteristics. And then when you're born, you're not identical to your parents. You're similar in many ways. You inherit some of its basic DNA, if you might think about it, and then it gets changed a little bit. So the children are a little bit different. They're transformed, they're translated, they're reflected, and what we will do is we will take parent graphs and we will modify them to create children graphs. So in Algebra 2, we're going to start off the year by looking at 4 different parent graphs that we previously discussed in Algebra 1. So here I'm just going to draw sketches of each graph on a very basic level, and then we'll dive into them a little bit more later. So a constant graph is just a constant horizontal line here at 1. A linear graph is, just as you might think, a line. So there's our parent graph, the linear graph, and again, we'll go through these in a little bit more detail later. The absolute value graph is a V-shaped graph, and the quadratic graph is a U-shaped graph. And that's not a great U, but this is more of a U shape. This is more of a V shape. Then we have the line and a horizontal line. So we're going to dive into these parent graphs a little bit later, but these are the 4 that we've already seen, we've practiced, and as a result, we're going to use these to start off Algebra 2 and understand parent graphs and child graphs on a slightly different level. Now in Algebra 2, there's some key vocabulary from Algebra 1 that we need to make sure that we know. The first is what is called function notation, and we will use function notation often to represent equations in our class. So function notation is, by definition, a fancy way to represent the y value of a function. So for example, we used to write something like y equals 3x plus 4. That is a linear equation, and what we do when we write that equation with function notation is we take this y value here and we replace it with a function name. In this case, I'm going to use f. So f parenthesis x parenthesis, that is called function notation. This is a fancy schmancy way of saying y. So we can, instead of writing y equals 3x plus 4, write f of x equals 3x plus 4. And what this allows us to do is, say we had a second equation, and that second equation was y equals negative 2x plus 7, is instead of having 2 y's that are currently on our screen, what we could do instead is we could give that function a slightly different name. So here I could use then g of x, and use function notation again, fancy way of saying y. So we have g of x equals negative 2x plus 7. So what function notation allows us to do is it allows us to have multiple equations on our screen, and we can then distinguish between them instead of having multiple y's and multiple x's. If we use function notation as a fancy way to represent y, we can actually distinguish between our different equations. Now, a couple of things to note here. Here in this f of x part, this f parenthesis x parenthesis, the parentheses do not represent multiplication. They do not. So do not think that this is f times x. This is actually a fancy way of writing y. So it is not like multiplication. The second thing is that this fancy schmancy notation of f parenthesis x parenthesis and then an equal sign means that your goal is to find the value of the function at x equals some value. So if you have notation later where you write f of 3, here you're trying to find the value of the function when x is equal to 3. So we can actually put numbers in place of that x and evaluate the function at those different numbers. And then finally, this last blank here says this is commonly read as f of x, or in the case of the second one over here, g of x. So when you hear me say f of x, g of x, I'm just talking about function names, and we're distinguishing between them by changing up this letter out in front. So this is notation that you should be familiar with. You looked at it in Algebra 1, and we're going to use that very heavily here in Algebra 2. The last vocabulary terms we're going to look at that we're going to use as we start looking at graphs in Algebra 2 are the words domain and range. And we looked at these and used these in Algebra 1 as well. So the domain, by definition, is the set of all possible input values of a function. So basically, when you're finding the domain of a graph, you're finding all of the x points or the x coordinates that are needed to make points on that graph. And as we explore graphs in this class, we will practice domain and range and get back into the swing of finding domain and range. So remember, domain are all the input values or all of the x values used to make points on a graph. And then range on the flip side is the set of all possible output values of a function, which are typically all of the y values. So these are all of the y values that you then need, or the output values, to make points on your graph.